Before I start, let me make sure the recording has started first. Yes, recording has started. Before I start, I'm going to talk about term test 2. And I was told that that week, for those of you who are in the second year, is crazy time for you all. Okay? So what I plan to do is we are still going to have our test face-to-face. There'll be 2 or 3 questions. I will provide a summary sheet or a formula sheet, and I hope to get the formula sheet to you next week, so you get used to it. And some of you say that's not the good news. The good news is all the questions, it will be from the homework. Okay, all the questions will be from the homework. There'll be about a 10% change. I might ask something different, but all the questions will be from where? Homework. Okay, so it's you, me, formula sheet, 2 or 3 questions from the homework. Are we clear? Okay, I understand that it's really busy time for you guys, and I have enough of online testing. Okay, yesterday or the day before, I had a very good conversation with one of our students. I'm going to see is she here. No. Hannah asked me a real good question. Her name is Hannah. Okay, anyone know Hannah around here? I don't know the last name, okay, but Hannah asked me a very good question. Hannah asked a question which is, I took it for granted, okay, and a student like you guys make my teaching better, make me not realize what is not clear. So I appreciate the feedback. Unfortunately, while trying to convince Hannah, I lost my temper. Okay, I will publicly apologize to Hannah. Okay, I did lose it a bit because I'm teaching her and my daughter was hungry. Okay, so that was not a very good time. That's the reason, but there's no excuse. Okay, so what is Hannah's question? She asked me a very innocent question. Okay, and I'll tell you what it is. Okay, so we want to find what is going on in the region C. Okay, so C, I will divide this into, so C is a region where it's filled, and I'm going to call this our point alpha. Okay, that's our point alpha. By the way, all these are available online, the figures. If you can go online to grab the figures on Avenue to Learn, you'll see it. Over here is alpha. Over here is beta. Okay, and we are in a situation where we have eccentric loading. Okay, this is a eccentric loading condition. So we know that the formula that we have to apply, if I were to sketch our transformation over here, so this is X, this is Y, and over here, this is rotation about Z, right? The formula we're going to apply is stress X is equal to P/A minus by mz over izz multiplied by y. Okay? Now, the issue that I have is how to determine mz. Okay? Now, this condition is very unique. Let me tell you what is so unique over here. Note that the applied force P or P prime is parallel to the centroid along the y-axis or x-axis. So what do I mean by that? Okay, is we have the applied force. The applied force over here is parallel to the centroid. So if this is our centroid, okay, P, the applied force is parallel to our centroid. Why is this so unique? Okay, most of the time, what we see is when we have a beam, right? We have a beam over here. If we have a applied force over here, right? Our centroid is on the horizontal orientation. Okay. If we want to find what is going on at point A, the moment at point A, it's very straightforward. Moment is force times perpendicular distance. You just P multiplied by L, and you have a distance from here to here, L. Okay, it's straightforward. So if at point A, I call a point alpha, I call a point beta, right? Does not matter, it's still P multiplied by L. Okay? Now, if it's parallel, as you can see from the example I have over here, Hannah come up with a very, very good, Hannah told me, Eugene, I'm pretty confused now. And I asked her, what is so confusing? And she had, or the perception is this, okay? So I'm going to call this distance, from this distance from here to here as A. From this distance from here to here as B. Okay? And we know that the distance is it. So she asked me, Eugene, isn't it correct that moment at point beta is equal to the force multiplied by D minus by B? Because the concept is, if I'm going to find point B, right? If I'm going to find point B, so formula is force multiplied by what? Perpendicular distance. Okay? So isn't this the right formula? And then if I'm going to find M multiplied by alpha, or point A alpha, isn't it equal to force multiplied by D plus by A? Is it D? Yeah. Okay, because the distance from here to here is D. And my answer to her is no. That is not the case. Okay. And it really, like, I took it for granted. Okay. I will put it at the centroid. The answer is no. The correct moment is equal to F multiplied by D. Okay? And I realize it's my bad, okay? I realize this, that I've been using it for so long, and I'm trying to force feed this into Hannah. That's where I think I lost it, okay? And as I said, my daughter was hungry. Hannah is not here online. Is Hannah here? Hannah is not here. Okay. So I was trying to force feed this into Hannah. And I realized that I was wrong. Okay? I cannot force feed into her. It's absolutely wrong. Okay? Can anyone tell me the reason why the moment either for point alpha or point beta is m equal to f times d? Anyone, please? Anyone? Okay. And as I said, my bad, okay? I became impatient and I found the reason. The moment that we are analyzing is the moment applied at the centroid. Okay. So if we were to look into the formula where stress X is equal to mz, okay, stress X is equal to mz divided by izz multiplied by y. Okay, if we look at this formula, okay, mz and izz, okay, like our shearing stress, has to be a constant regardless of location. How do we compensate for the location? We compensate based on the distance from the centroid. The y is the compensation. You don't compensate the moment at all. The moment is constant. The y compensate for the what? The location. Are we clear? Okay. If I can convince you on this, okay, I believe Hannah will be convinced also. Does that make sense? Yes or no? You cannot compensate twice. You cannot say, I'm going to apply this, and then I'm going to compensate again for the what? The distance. You can't do that. Okay. Now, why this is important? When we do compound loading, okay, you're going to see a lot of this. And I think I just broke, or by talking to Hannah, I just realized why term test 2 students don't do well. One of it is this, because this is the root of the analysis. When the root of the analysis is wrong, everything is wrong. Okay? So I still remember. Any questions from here? Anyone, please? I want to see online. Any questions? No one has questions? Okay. So now, if we look at this problem over here, okay, we have done this before, by the way. Okay, we have done this before. So the situation over here, like what I have described, is you have a centroid over here. This is our position of our centroid. Okay, and the question asks us to find the stress at point alpha, or point A, point B, or point D. Okay, so based on what I've just mentioned, right, the moment, right, so the centroid is 8.154 millimeter from the what? From the top. Okay, so the moment about the z-axis is equal to 400 multiplied by 50 times 10 to the power minus 3. Now, 50 times 10 to the power minus 3 is at the top over here, right? And then we have to include the what? We have to include the distance to the centroid. So this is the distance to the centroid, and that will be equal to 58.154 times by 400. 23.261262. Newton meter. Okay. Are we clear? This is important. Okay. So from here, any questions, anyone online? Anyone have question? Don't worry too much about the guys with fries and gravy. Okay, you'll be sorted out globally, so don't worry about him. Putin, if you did not get the joke. Okay, fries and gravy with cheese. Right. So now, okay, we will carry on with our example that we do. Okay, we will carry on. So I'm going to take what we learned. Okay, so I'm going to carry on with the example. So on Monday, let me draw over here. Okay, on Monday, we started